Hello, everyone, and welcome to another Search Engine Journal webinar. Today, we will be joined by Dawn Anderson from Berkeley, who will be talking all about BERT, which God knows we've heard everybody talking about it recently. And luckily, we have one of the world's best here to tell us all about it. And I think you're really going to enjoy the conversation. My name is Brent Satoris. I will be moderating today. Dawn, just give us a little feedback about yourself, kind of your experience before we jump into some housekeeping points.
Okay, hi, thank you for inviting me to come on this webinar. I really appreciate it. I'm Dawn Anderson from Manchester in the UK. I run an agency, a boutique agency called BERT, which was actually named after my dog, not Google BERT. There has been some confusion about that amongst people just recently, but it was a coincidence. And I've been in search for about 13 years now. In addition to being a consultant stroke agency owner, I also lecture on digital strategy at the university, and I also supervise master students in digital marketing strategy. So I'm very intrigued by both the practice side of search, and I'm actually really intrigued in the whole information retrieval and academic research side of search as well. So that's part of the reason why I know quite a bit about BERT as a research paper, because I've been following the whole information retrieval side of things for about a year before it came into actual search. So yes, I'm looking forward to talk about the topic. It's very intriguing and very exciting times.
During the entire webinar, any references we make to any tools or resources, we'll do our best to make sure these get linked in the recap article. And just so you note that after this webinar is completed, we will be doing a full recap post. It will be available on Search Engine Journal. It typically comes out the following Monday, so look for it this coming Monday for a full recap. That way you can kind of listen again, or you can share it with friends, or you can take better notes. And without any further delay, let's dive into the webinar.
Okay, thank you. Thanks for that introduction, Brent. I'll press on now then. Okay, so what are we talking about? BERT explained what you need to know about Google's new algorithm. Don't need to go on too much about this. I've already introduced myself, or Brent did earlier. But also, just as a slight aside, because I always bring these two beasts into my presentations wherever I go. These are my two Pomeranians, Bert and Tedward. Bertie is the namesake for my business. And as I say, I'm convinced that Google named Google BERT after Bertie, but probably didn't. Okay, so we're not talking about Pomeranians today. We're talking about BERT in search. Because just recently, Google announced that they were introducing something called Google BERT into their algorithm, and it was supposed to understand search better than ever before. But what does it actually mean? Because we've obviously seen lots and lots of people drawing conclusions and quite a lot of guesswork going on out there, and Google have said that it will impact 10% of searches, which is not trivial, obviously. And it's also going to impact featured snippets as well as normal rankings. So what BERT really is, well, the important thing is BERT is actually many things. So whilst you may have heard of Google BERT as a Google algorithm update, it's actually much more than that. BERT, as we know, and as we've said, is a Google search algorithm ingredient. It's a tool, if you like, for natural language understanding. It's a framework as well within search called Google BERT that Google uses to actually try to understand the way humans interpret language and what they actually mean in the nuance of words glued together almost. But BERT is also, and this is really important, an open source research project and academic paper that Google produced a year ago in October 2018. And here's the paper. It's quite academic, but it's well worth reading if you want to get your head around the foundations of what BERT's all about. The meaning of the word, if you like, well, the name actually comes from its full name. The anagram comes from its full name, in that BERT stands for Bidirectional Encoder Representation from Transformers, which is quite a mouthful, obviously. And I'm going to run through a bit later what that owl actually means, but it's probably best that we just refer to it as Google BERT because it's much easier. But basically, it's a natural language processing framework which Google produced, and then they open sourced it so that the whole natural language processing research world could actually get better at natural language understanding overall. And what you'll probably find is that most mentions of BERT online are not about the Google BERT update. In that, there's lots and lots of actual papers about BERT being carried out by other researchers that isn't using what you would consider as the Google BERT algorithm update. They're using the BERT framework to do research papers. So, you know, it's more than a search algorithm is the point. What BERT overall has done is it's dramatically accelerated natural language understanding more than anything probably ever. I mean, natural language understanding as a field has been around probably since around the 50s/60s, when the Turing paper came out and the whole philosophy, the whole theory of can we teach machines to understand language. So it's been around a long time. BERT has probably been the biggest thing to change progress, to accelerate progress in that field since ever, really. So naturally, there's such a huge change, something that actually allows machines to understand language much more than ever before, has caused a lot of excitement amongst the machine learning and natural language processing community. They're obviously very, very excited about BERT. And part of the reason for this is that BERT takes a huge amount of heavy lifting out of them being able to carry out research in natural language understanding, because BERT is almost like a pre-trained vanilla package, a bit like you might get a vanilla version of WordPress or a vanilla version of a module for a content management system that you then improve upon. Basically, BERT provides a layer or a foundation for natural language processing researchers to then fine-tune and customize, if you like, to do more important and more granular downstream natural language processing tasks. And actually, BERT's been pre-trained on a huge amount of words to understand language at a very basic level, not too basic, but at a level that's not quite perfect. It's actually been pre-trained on the whole of the English Wikipedia, and in actual fact, the whole of what they call the books corpus as well, which is about another 1 million words, so a lot of words. Okay, so as I say, it's pre-built as a basic level, and then these natural language processing researchers can extend on it, as search engineers can as well, fine-tune it, build better models, etc. So various versions of BERT. Everybody out there wants to build their own BERT, and you'll see lots and lots of versions of BERT, but with different names. So it's basically trained on Wikipedia, but then it is fine-tuned on other things like questions and answer data sets. So pairs of questions and answers. So here's a question, what would be the most probable answer? That kind of thing, to just keep making it better and better and better. And it's self-teaching as well. So it loops back round and actually teaches itself, carrying forward the learnings. One of those data sets, those question and answer data sets, it can be fine-tuned on, is called MS Marco. MS Marco is what they call human-generated machine reading comprehension data set. Now, actually, what it is just real Bing questions and answers, queries from real Bing users that's been built into a data set with questions and answers for machine learning and natural language processing researchers to fine-tune, and then they actually compete with each other to build the best model. So things like this MS Marco, which was built by Microsoft and open sourced, actually has a leaderboard as well, so that people use the model, test it, train their models on the questions and answers, and then they submit to be the leaders on the MS Marco leaderboard. But you can see here that the MS Marco dataset, which anybody can use, has actually been built on over 1 million real Bing user queries. So that's how these are fed. So you can see that search engines ultimately fine-tune on their own queries. As I said, there's lots of other ways in which these researchers actually compete as well. There's another one called the Stanford question and answer data set, which is basically, again, questions and answers. It's from Stanford. There was a one called Stanford Squad, they call it Squad 1.1, but that actually became quite easy. And then they brought out Squad 2, which actually includes harder questions and what they call adversarial questions as well. So questions that are there, almost like trick questions, to see whether the models can actually understand what they don't know. So yeah, so to make them realize, well, I don't know the answer to that type thing. So you can see this is literally like training machines to understand language, and language that they don't actually understand as well. It's very advanced, yeah. Now even beats human reasoning on the squad benchmark. So because humans aren't perfect, BERT now beats humans at question and answering. So lots of other massive AI companies are also building BERT versions because it's open source. Anybody who has a mind to can go off and take that model and extend upon it. Microsoft, for instance, extended on BERT with something called MTDNN that actually then beat BERT. So they kind of all leapfrog over each other, taking the model, building on it, then they open source it. So somebody builds on top of that, then that gets open sourced, and it just goes on because it's just escalating because everybody's like working, all these researchers are all working effectively together. It's almost crowdsourcing learning. And then you've got Roberta from Facebook, which literally stands for a more robust BERT. Basically, Facebook turned around and said, hey, we don't believe that BERT, the original BERT, was trained enough. So we're just going to train it more. And then they produced a better version called Roberta. So there's loads of them. If you look on any of these leaderboards, like Squad, like this one, Superglue. Superglue is another benchmark that they use. You can look all of these up. This was created because there was an original one called the Glue benchmark. Another, they've got the code, the training sets, the tasks that the machine learning models use to try and beat each other. So it's all there. Anybody can join it. And then the leaderboard obviously has the leaders who are getting the best models out there. But Superglue was built literally because glue was just blown out of the water by the models because it was too easy. So, and this is all in the space of a year. So can you imagine the progress is going to happen into the future if this has been what's happened within 12 months. So, well, what challenges does BERT overall help to solve? Google's original BERT model and a lot of what actual machine learning and natural language processing researchers have been doing over the years. Where's the challenge? What's the difficulty with natural language understanding? Well, we have to look right back at language overall to understand the challenges that are there. Things that we understand easily, machines don't really understand at all, including search engines until probably BERT. The problem with words, they're everywhere. We know that more and more content is out there. Words are just voluminous, voluminous, more pages than ever. Long form content is, massively difficult to understand because there's just so much of it. And the problem with words mainly is that they can be problematic because there's many ambiguous words with multiple meanings, sentences, well, actually words are not ambiguous. Words are polysemous, or they're homonyms, or they are synonyms. But actually, ambiguity is at a sentence level because once you start to put together words that are polysemous or homonyms or synonyms, the sentences become very difficult to understand. So the sentences tend to have more than one meaning and they become ambiguous. So BERT is designed to solve or help to solve ambiguous sentences and phrases that are made up of lots and lots of words with multiple meanings, if you like. Because look, polysemy, almost every other word in the English language has multiple meanings. So if we look at this, bass or bass, whichever way you want to pronounce it, that could be a sea bass, a freshwater bass, something to do with tone, singing, voice, a type of singer, so many different meanings. Almost every other word in the English language is has multiple meanings, which is really challenging for machines to understand. And it's actually worse can be worse in spoken word, because the notion of homophones and prosody as well, accents, different regional accents, intonation, the highs and lows of conversational search as well, the way that people speak to emphasize things. And obviously, sometimes you can have 2 words or 4 words that when you put them into pairs, like phrases, individually those words don't have any kind of crossover in meaning, but the minute you add them together, they tend to start meaning the same thing. So for instance, if you say 4 candles and 4 candles, and you're of a certain English accent, then these two phrases, both 4 candles and 4 candles, suddenly become ambiguous because they sound like they mean the same thing. And actually, there's a lot of comedies out there that are about play on words. Lots of comedians, some of their jokes are based on the play on words, because words are very easy to misinterpret. It's just very challenging. Not so much for us, because we have common sense, context. We can understand all the other words that surround the context of the situation, the conversation, but search engines and machines, not so. Naturally, we know that search engines are pressing forward with conversational search, assistant, Google Actions, and so forth. This is increasingly important. Chatbots need to be able to understand, what people meant when they either put things into text, or when they speak things. So things like homophones are really challenging in the face of conversational search. Part of this also comes down, part of the issue with words context comes from a long, long time ago. There's a philosopher called Ludwig Wittgenstein, and basically he said the meaning of a word is its use in a language. Well, what does that mean? Basically, it just means that a word kind of has no meaning unless it's used in a particular context. I'll give you an example of that. The meaning of a word can change as a sentence develops. And it's partly due to the multiple parts of speech that a word could be given in a given content or context. So let's look at this. This is using what they call the Stanford parser, the Stanford part of speech tagger online. So basically, a part of speech tagger looks at a sentence and it takes it all apart, and it attributes things like adjectives, nouns, verbs, and so forth to the different parts of the speech to sort of pull it all together to give meaning, if you like, to a sentence. But you can see here that like is in this sentence more than once. So at one point it's an adjective, and the next, it could be a verb, a noun, or an adjective, depending on the part of the speech that it's in. It's in the part of the sentence. So literally, like has no meaning because it can mean whatever it is, whatever surrounds it. So the context of like changes according to the meanings of the words that surround it, if that makes sense, and hopefully it does. This is where the challenges are. So the more we speak, the longer the sentences, the harder it is to keep track of all the different parts of speech that might be involved in a particular sentence. As I say, natural language understanding requires understanding of context and some common sense reasoning. And this is really challenging for machines overall. But it's not structured data. I've seen some blog posts out there, and a few people say, hey, BERT is all about structured data. BERT is not about structured data. Natural language understanding is not about structured data, actually. Structured data is used to disambiguate with entities, etc. Structured data is about, turning strings into things and adding, disambiguating entities, things, if you like, in web content out there, and tying together things that are the same and giving them a specific ID number, etc. Structured data doesn't just disambiguate between the mess that's in between. So all the words like the likes, the like, and the tos and the froms, and all these random words that they're not necessarily entities, they're just the context that's needed from all these tiny words that change as the sentence develops. It's kind of the hot mess in between. Obviously, not everything is mapped to the knowledge graph either. There's lots and lots of, I'm not in the knowledge graph. Majority of people are not in the knowledge graph. Majority of streets are not in the knowledge graph. Lots and lots of things out there not in the knowledge graph at this moment in time. And obviously, millions and gazillions of words are not particular entities as such, or even concepts. So there's lots of gaps to fill in, and that is where natural language understanding comes in, because it starts to fill in the gaps. So here's an example of ontology-driven natural language processing. So you can see here, we have all these entities and the relationships between them. Hamlet is a type of whatever, a play, and it was published in, date, and the author, type of, etc. So these are called is-are relationships. Well, actually, natural language understanding fills in the gap between all the is-are relationships. Natural language processing is kind of quite big almost. So it's kind of filling in all these gaps, like as the, in the, etc. So how can they fill in those gaps? So natural language disambiguation is needed. And some of it also comes down to this other notion as well. A lot of linguistics, if you like, come back to what they call Firthian linguistics, and it's called words company. You shall know a word by the company it keeps. Basically named after John Rupert Firth, who basically said, look, words that are live together in a big body of context or a content, a book or a language, they tend to be related. This is the notion of co-occurrence, similarity and relatedness. Yeah. So words that are similar kind of have similar meanings. Words that are related form this whole like is-are thing. So a car and a bus are related because both of them are vehicles. Yeah. But things that are similar might be, things that are related might be a road and a tyre and a pavement and or a sidewalk, as you call it, and pedestrian, that kind of thing. Those are kind of related, but so it's just about connecting all those relationships together, if you like, in a body of text. So part of the way that works is that language models can be trained on very large text corpuses or collections of words to understand these, what they call distributional similarities, part of computational linguistics, and it all comes down to maths and where words live together in mathematical spaces because they can actually be mapped to be in these tiny spaces, what they call vector spaces together. Yeah. Quite difficult to explain, but basically, as I say, it all comes down to maths and linear algebra and understanding where a king sits next to a queen and a man sits next to a woman and the relationship between those two, to understand things like verb tense, countries, and so forth. So that's a big part of computational linguistics, where they actually build these vector space, linear algebra, tiny like mathematical spaces where words sit together. And that's kind of more or less explaining the same sort of thing. So these are contextless word embeddings. They don't actually have all the words that surround, like the sentences. They have just this relationship of things that live together. So they don't have the text cohesion and at the very early stages of mapping similarity and relatedness together. So what search engines have done historically, and natural language processing engineers and researchers, is they've built models that have learned the distances between concepts using these notions of similarity and relatedness, and then use those to train language models themselves. But a big part of it obviously has been very laborious. They've had to use things like machine learning, skipgram, and a continuous bag of words, literally like feeding in sentences and word pairs to try and understand how these words all fit together. Very time consuming, building like data sets, if you like, quite labor, if you like, computational expense, and also resource expensive as well. But also another thing, even if we understand the entities, we need to understand the word's context. Yeah, so I'll give you an example. So we might understand what a bucket is, yeah, but without the context of a sentence to go around it, a bucket means nothing. So because on their own, a single word has no semantic meaning whatsoever, yeah, and they definitely need this whole like notion of text cohesion. Because as I said, a word bucket would mean anything if you didn't have a sentence to surround it. So I'll give you an example. He kicked the bucket. I've yet to cross that off my bucket list. The bucket was filled with water. You know, all of those things mean different things. He kicked the bucket. Most people would presume that means it's slang for he passed away. I've yet to cross that off my bucket list. Well, that's a list of life goals, and the bucket is the obvious one that we would probably think of in our mind, but you know, in a sentence, it has a different meaning. As I say, another part of the big important part of linguistics has been what they call this part of speech tagging, which I showed you earlier, where different parts of a sentence, when you join it all together, are tagged up with these parts of nouns, adjectives, and so forth. And there's various different types of part of speech taggers. Some of them, linguistics have extended them massively now. They actually go into like noun, past tense, third person, etc., and start to really build out. I think the Pentree Bank tagger has something like 136 different parts of speech that a word could possibly be, or different tags. So again, I know that a big part of some of the big search engines, conversational search and assistant projects, have been around employing big teams of linguists to tag up and train machines to how to understand words meaning or human language. Google had a huge project called Pygmalion, which literally was like loads of PhD linguists all tagging up data sets. So again, all very resource intensive. Okay, and as I said, this is just showed you how it all looks when you start to break it all down into chunks of words and tokenization. Tokenization literally is just breaking a body of text down into different words. So, and then adding things like the, NP, DT, determiner, etc. with the parts of speech. And there's an example. But it's wrong. Some of it's wrong because what happens here, it doesn't actually pick up on the named entity or the entity which is search engine journal. It literally takes apart the three words and has them all just individually as nouns because search is a noun, engine is a noun, journal is a noun. So, it really needs entity determination to put that all together and say, hey, this is an online publication called Search Engine Journal. So these things can be wrong. But the point is, this is where the likes of BERT does come in and actually helps to make understanding of language better. So how does BERT work? Okay, so the big challenges has been this context-free embeddings. So they built historically word embeddings, and obviously they didn't have all the context of the sentences around them. So that's a massive bonus that BERT brings in. BERT brings context more than anything. Yeah. So because BERT is pre-trained on such a vast amount of words and then fine-tuned on things like question and answer data set and other natural language processing downstream tasks, the context is just continually learned of all of the words and how words fit together, and words meaning, if you like. We've covered this. Another big deal, probably one of the biggest things about BERT is it has this bidirectional, and again, it's the B in BERT stands for bidirectional. But what does that really mean? So, I mentioned before about skipgram and the skipgram model and continuous bag of words, how machine learning, natural language processing engineers had fed word pairs and sentences together, and they'd looked at words context to try and understand how the different meanings of words in a given context. So the way that they've done it is they've fed in words through this, what they call a moving context window. So they have like maybe a word, say this target word is will, and then on the either side you have a word's context window of X size. So is it 3? Word context is 3, the context window is 3. So 3 either side, or it could be that it's 3 but there's nothing on the right hand side, there's nothing on the left, whatever. It just means that basically it's trying to understand the context of a word in a given sentence or phrase. But basically, the words are fed in and they're moved along in a direction. But the problem is, and this has been the biggest challenge, is the words have moved all in one direction. The language modelers have moved in what they call a unidirectional way. So the words and the past in the sentence are fine, the context is understood, but the context of the words to be seen in ahead are not seen at this stage, because only the words to the left have been understood. If it's a left to right, call it a unidirectional model, or the words to the right have been understood if it's a right to left unidirectional model. Not both sides of the sentence at once. So in the example of sentences there as that target word, the context in a unidirectional model left to right only takes into consideration, you know, writing a list of random sentences, yeah, with sentence at the target word, yeah, writing a list of random. Well, that could mean anything. So actually, until you get further on in the sentence, you don't actually understand the context, yeah, because at that stage is harder than I initially, isn't actually included in the contextual and, you know, meaning, if you like, on these unidirectional models. BERT is different. BERT is able to understand both sides or all sides of the sentence at any one time. So it understands, in the instance of sentences, that writing a list of random is harder than initially, you know, in that context window, yeah. So it understands everything together. And I mean, as humans, if we only understood half a sentence, probably struggle to understand, probably struggle to guess what the rest of the sentence is about or what you actually meant. It'd be like, you know, just talking to somebody but missing out lots of bits. So this is a huge, huge thing. So you can see the whole sentence and all of the words at once, if you like. So in actual fact, it understands things like riverbank and bank deposit, where because it can see. So if I said I crossed the road to go to the bank, so I crossed over the bank, it understands that you're talking about financial bank because it understands the rest of the sentence that might be to make a deposit, because deposit and bank go together in a financial context. Whereas if you'd said I crossed over the bank to get to the river, yeah, again, joining river and bank together is a completely different context to a financial bank. So this understanding of both sides and all around the sentence makes a huge difference, and that's where BERT's big plus is, if you like. So encoder representation, this is very, very simple. Basically what it means is it's basically the words going in or the sentences going out and what gets decoded. So decoding and encoding. So it's an in and out mechanism. There's not a huge amount to go on about there. Basically it's just the E and the R from BERT. The T is a big part, the transformers part. This is based on something called BERT uses this notion of transformers and what they call mass language modeling. So basically, transformers is, so here, transformers basically. So one of the big issues with natural language understanding in the past has been this notion of search engines not being able to understand in what context a word is referring to. So pronouns, for instance, it's very easy to lose track of who somebody's talking about in a conversation. Even humans can struggle to keep track of who's being referred to in a conversation over time. The minute you start to say, well, my auntie's uncle's brother's sister's wife, it's very hard to keep track as a human. That's kind of similar for search engines, but they struggle to keep track of when you say he, they, she, we, it, etc. So actually the transformers attention part of this actually focuses on the pronouns and all the words meaning that go together to actually try and tie back who's being spoken to or what is being spoken about in any given context. So it's about focusing attention on, if you like, the whatever is the specific attention focus topic. Yeah, so a little bit obsessing on the entity that's being referred to and in what context. The mass language modeling part basically is almost like, because the attention mechanism and this bidirectional thing, this bidirectional sentence ability to look in both sides of a context window, the mask is needed because it prevents the word that's under focus from actually seeing itself. It's almost like, I suppose we could just say, it's a little bit like a fix for an infinite loop, which we could have on a normal computer program. So it's almost to stop a bug almost looping round, if you like, and just flowing all the data ridiculously. So and the mask is in place, and what happens is BERT just guesses at what the missing word is, if you like. It's part of the fine-tuning process as well. So that's from a paper called Attention is All You Need, or All You Need is Attention, that was out the year before BERT came out. So it came out in 2017, I think. So basically, BERT, as the research paper, built upon various other things, including other people's past work. So, you know, they're not the first natural language processing model out there. Lots of others have done previous work that's all built up towards this, but BERT was just a really big breakthrough. You've got the likes of Elmo and Umfit and various others that have obviously contributed very, very important work out there as well. And then obviously Attention, the Attention paper came out, and then BERT came out as well. So what types of natural language processing does BERT help with? What kind of tasks? And where's it likely to be implemented in search? Because obviously that's the most important thing to the viewers or listeners here today. So it's going to be things like named entity determination, you know, understanding which of various named entities is being referred to in a given context. Textual entailment, which is next sentence prediction, and I'll go into that slightly later on. Basically, it means guessing what sentence comes next. Co-reference resolution, that's about understanding the thing I said about pronouns. When you talk about various people together or various things together, which of those is being referred to in a given context? Question and answering, yeah, that's obviously a really big deal, because we know that question answering is a huge part of search. And obviously things like featured snippets, people also ask that kind of thing. Word sense disambiguation, the likes of, you know, does Apple mean Apple, or is Apple referring to the huge tech company, or, you know, is a scone something, is a biscuit and a scone a similar thing in the US to the UK? And things like two and two, which are really one of the most difficult types of words to understand, because they are rooted in the same language. They have the same language roots, potentially. And then automatic summarization, which is obviously things like news summaries and, again, featured snippets. And polysemy resolution, that's words that have more than one meaning being resolved. Well, when BERT was announced, BERT literally extended the state of art on 11 natural language processing tasks. There are more natural language processing tasks. If you go on Wikipedia, you'll see a category called natural language processing tasks. There's absolutely loads of them. But this is, you know, a huge area, the whole computational linguistics area. But BERT advanced the state of the art on lots of them. And BERT's obviously been bettered now by others. Again, things like this notion of polysemy and homonyms, words that have multiple meanings, and words that are, again, some synonyms are different, but BERT also helps with the likes of synonyms, things that actually are similar, if you like. Co-reference resolution, as I say, pronouns that can be very problematic, because computers lose track very easily of who is being spoken about or referred to. And this notion of anaphora and cataphora is where this all comes from. So what does that mean? So if I say, well, anaphora is referring to an entity with a pronoun, usually much later in a sentence. So if I say something like, Bertie the Pomeranian went to the park with her owner, and then she played with the other dogs. So she, in the context, is an anaphora that refers to Bertie the Pomeranian, or Bertie, yeah. What about cataphora? So cataphora is much less common than anaphora, but cataphora refers to a pronoun that refers to an entity that's not actually yet been mentioned. So it could be, she enjoyed going to France, and Dawn told everybody. Yeah. So she enjoyed going to France, and Dawn told everybody how much she enjoyed it. So she would be referring to Dawn, but Dawn hasn't yet been mentioned in the sentence. So that's cataphora. So anaphora and cataphora have been quite a challenge over the years in linguistics, computational linguistics, and is part of the whole like co-reference resolution, and also a big part of where the whole attention comes in with BERT. Named entity determination. So what this means is that named entities are things like Mozart, Neil Armstrong, things that are entities and have proper names, and we all kind of know about them, if you like. But there are more than maybe one Neil Armstrong on the world, yeah. There might be more than one, Dawn Anderson out there. There might be, certainly there is lots and lots of places in the world with names the same. So Manchester is in the UK, there's a Manchester in the US. I believe there's one in Canada. I believe there's also one in Australia. That is kind of an example of named entity determination. So that sometimes needs a lot of context around it to understand exactly. If you're looking at a plumber in Manchester, is it referring to Manchester in the US, the UK, Australia, Canada, etc.? Yeah. So the point is, named entity recognition is not named entity disambiguation. Yeah. Just because something's recognized doesn't mean that they understand which one of several or more than one named entity has been referred to. Yeah. Because named entities can also be polysemic. Yeah. More than one. Yeah. So did you mean Amadeus Mozart when you refer to Mozart? Did you mean Mozart Street? Did you mean Mozart Cafe? There's loads of ways that people refer to Mozart. There's loads of ways that people refer to mobile phone. And Wikipedia have like this notion of one concept, one page, and anything that's, if you like, a disambiguation of say mobile phone, they use this thing called Wikipedia redirects to redirect everything, like this one concept almost. And also verbally, when you come again, it's coming to this whole like conversational search area. Lindsay Doyle or Lindsay Doyle. It's easy to like confuse the two. When people are speaking, it's harder than when it's with words, yeah? So named entities are mined in unstructured data again. Wikipedia is amazing for this. We know that, Google's Gary Esch in a Reddit asked me anything, I think it was last year or maybe back end of last year. He was asked, well, what's the point of brand mentions in content if there's no links? What's the point of it? What are they used for? And I believe he just said entity determination. It's basically understanding who the brand is that's being spoken about and kind of aligning all these signals to a kind of correlation, if you like, and understanding potentially what context that brand is spoken about in. So if I'm spoken about in the context of SEO, potentially Google might understand that I'm an actual SEO, even if there's no link to me. So textual entailment, this is another big one. Next sentence prediction, potentially massive into the future for things like conversational agents. Like to understand, well, what's the next sentence that's likely to come up? Can I predict what the next sentence might be so I can potentially line up an answer, that kind of thing? And obviously, sometimes more than one. So may also be part of things like people also ask to understand that, potentially paraphrasing as well. But textual entailment is a big thing, this next sentence prediction notion. And I believe, I'm not mistaken, that actually Google BERT, the original research paper, had some flaws with textual entailment, next sentence prediction. And I believe that from what I was reading, Google have brought out in a collaborative work with Toyota a model now called Albert, which supposedly corrects or improves upon BERT's failings on textual entailment. But anyway, the point is that is next sentence prediction. So So when two choices are given, part of the whole natural language training tasks that are provided in some of the leaderboards and the data sets are, here's two sentences, which one's likely to come next, which one makes more sense, yeah. And there's actually tools out there where you can, I think Hugging Face has a lot of stuff on this. If you look on Hugging Face, has a great amount of resources where you can put one sentence in and it spits out another sentence. I think Fast AI has some other stuff as well that's really good. There's quite a lot of, if you look up textual entailment, you'll see quite a few tools out there that allow you to test this and to see, you know, what sentence is likely to come next, and to almost like test small models. And the next sentence really matters often, yeah. So BERT is able to understand, for instance, I remember when my granddad kicked the bucket, that sentence, presumably somebody might mean one thing, but actually it could mean, how far do you reckon I could kick this bucket? Well, the second sentence there actually changes the whole meaning of the first sentence. So it actually makes a huge difference when you have these big bodies of text and questions and answers. So how is BERT going to impact search? Well, you know, and BERT, Google have already said this. BERT is going to help Google to better understand human language. I think the challenge is obviously BERT is so many different things. BERT is like a Swiss Army knife of lots and lots of different areas where parts of search could be trained to disambiguate queries with lots of nuance. As I say, words like two and two can suddenly change. They're like, they sound the same when you speak them, but they have lots of different meanings. I believe there's words like the word get or run one of them has 600 different potential meanings. So actually understanding those words for search engines is going to make a massive difference to how they interpret queries, because people are searching obviously with these more long, these almost like questioning queries now, almost longer queries, and especially when they're asking questions as well with voice search. So that's going to make a huge amount of difference. I know I read quite a lot of stuff about Pygmalion, the issues that Google had with Pygmalion last year. Even this year, there was quite a bit of write-up about Pygmalion as a project being a challenge, where they had all these linguists sitting there like doing part of speech tagging, training data sets in a semi-supervised way. And 2 or 3 years ago, one of the product managers was saying, one day we hope that a lot of this is going to be automated for scale. Well, BERT potentially massively allows scale with featured snippets, summarization, and the whole internationalization of conversational search. BERT also has this notion, I think, of even though obviously there's hundreds of languages in the world and loads of languages, for Pygmalion to have scaled massively, you needed to have linguists to translate everything into different parts of speech in any given context for every language of the world, which is not a trivial task. I believe that BERT almost has this monolinguistic to multilinguistic ability, because a lot of patterns in language do translate into other languages. So for instance, there are some really big phenomenons actually in language. There's something called the Zipfian mystery, the Zips mystery, in that the frequency of words in a distribution in any language anywhere in the world is usually directly proportional to 1 over its rank. Meaning, well, in English, the most commonly used word is the, and then it goes in an order. So the second most used word is used half as much as the third most used word is used a third, a fourth, and it just goes on and on and on. That's why we end up with the long tail distribution. But that pattern can be rolled out to any language of the world. So computational linguistics with machine learning and something like potentially BERT being constantly made better by other researchers as well, has the ability to transfer a lot of the learnings to different languages, even though BERT doesn't necessarily understand the language itself fully. Yeah. So that has massive potential to hockey stick conversational search internationally, potentially. So as I say, expect big leaps there for international SEO potentially going forward, because we know that the vast majority of the web is in programmer's English, even though it's not the most commonly spoken word as most commonly spoken language in real terms. So that could be massive. Contextual nuance is just going to be big as well. There's going to be potentially, well, I've seen there's a lot of people being impacted and complaining that their rankings have been impacted, etc. But I think that that's probably more because Google's suddenly got better at understanding the nuanced context of queries and the nuanced context of content. So perhaps historically where they've been a little bit guessing because they've had words missing, these contextual glue missing, they've had to kind of just throw the best results out there, getting as much recall and as good as precision as possible. But I think precision overall, the more accurate results are going to improve. That would mean, obviously, if the more accurate results are going to improve, quite a lot of people are going to like drop away for things that they weren't actually that accurate for in the first place. We'll probably start to see some drop off in impressions because of that in Search Console, because we're not necessarily going to be recalled in a set of results because suddenly Google understands we're not that relevant for it. So yeah, so I think that's going to be big. Google's probably going to use the Swiss Army knife of all these different tools that Google BERT and the other improved natural language models provide in lots and lots of areas going forward. And it's self-teaching as well. So they have like these feed-forward recurrent neural networks, just keeps teaching itself to get better. So expect it to continually fine-tune. Yeah. Should you try and optimize your content for BERT? Well, you know, probably not. Google's Danny Sullivan has said no. I think the point is with Google BERT, it's many things. It's just many things. It's a bit like saying, hey, should we optimize our content for Photoshop? Yeah. Well, Photoshop's a tool. Google BERT's a tool. It's like saying, should we optimize our site for a tool? Yeah. So it's not. It's a framework. It's a framework of better understanding. It doesn't judge content per se. It just better understands what's out there, which might inadvertently mean that, for instance, Google BERT might suddenly understand a lot more, and maybe there are pages out there that are over-optimized that suddenly might be impacted by something else like Panda, because Google's BERT suddenly realized that this page had, you know, it wasn't that relevant for something, or it was a little bit over-optimized. That's not to say you're optimizing for BERT. You're just probably better off just writing naturally in the first place, and you probably weren't. If you weren't writing naturally, the whole point of BERT is to negate the need for this keyword-S language that searchers have, because they presume that search engines don't understand them. And the same, so we don't necessarily need to do lots of keyword stuff in. We don't necessarily need to write in such a way as we have in the past. I know that for voice search, there was a lot of, you know, it was, when you looked at the quality raters guidelines that came out last year for voice search, it was very prescriptive. It wasn't that good. I think this is going to be so much better. So I think we don't have to be quite as keyword-essy, if you like. And actually, this is a black box algorithm as well. So there's no search engineer out there, no Danny Sullivan, no Google, no John Mueller, no Gary Ed. He's going to be able to turn around and say, hey, well, BERT made this decision because of X. Because this is a black box algorithm that just continually learns and teaches itself and improves based on its learnings, yeah? So there's even this field that the likes of Hugging Face has created, a field of study called BERTology now. And this is the study of trying to work out why BERT made certain decisions. Well, if a field is out there called BERTology, what is there much point of SEOs expending massive effort and time trying to optimize for BERT when they could just be creating something really good and compelling for humans, which BERT is designed to kind of understand? So, you know, who am I to judge? But I would say probably not. So as I say, it's a black box algorithm which comes not without its own challenges. And also bear in mind, sometimes some of these BERT models can have hundreds of layers of lots and lots of other factors built in, tuning and weights and features. So, you know, nobody can optimize for that, if you like. And also another thing as well that's important, this could be BERT by name, but not by nature, in that the original Google BERT was a research piece that wasn't perfect. It did beat state of the art on 11 natural language processing tasks, but it's been there a year, and people have run with it, and people have improved on it, making it better, beating these benchmarks across all the different leaderboards. The chances are this is just BERT by, they've named it after the original BERT, but in reality, production BERT is probably quite a bit different and much, much better than research BERT. So, and it's going to get better as well because we're only a year in. So imagine. So yeah, so it's going to be increasingly difficult. So the point is just, it's not that we've not got a job. We still have a great job to do. SEO still needs to help search engines disambiguate, because there's still going to be issues with things like canonicalization. There's still going to be issues with, you know, entities that still can't be understood. The key is still to build good structures, still to build great compelling content, still to think about accessibility and semantic headings, because they're not there just for SEO, they're there for humans as well. But if you think in that regard, I find it often helps massively with SEO in the first place. And I think, you know, one other point to note is that we're only a year in, but the size of the BERT models that researchers were producing was just getting bigger, 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 bigger. They weren't necessarily actually improving things, because what's happening is they're just training more data, spending more money. Eventually now, other models have come out that they've had to think, well, we need to scale this down a bit and become more efficient. So they're producing models now like DistillBERT, FastBERT, and Albert. Albert's the piece I mentioned between Google and Toyota. DistillBERT is a piece, a model by Hugging Face, and I do urge you to go and look at some of their stuff, because they have actually all the open source models there in a library that you can use to build your own BERT pieces of research, because BERT can be used for loads of things. I know, for instance, that I saw this morning that 2 or 3 of the different SEOs that I interact with are actually implementing BERT on various pieces of work, like Hamlet Batista, Andreas, Cyber Andy, and J.R. Oaks has just done a really funny one about scones and biscuits on Twitter. So he's really digging into it. But there's loads of stuff out there. I really encourage you to take this and look at ways in which you can maybe utilize BERT within your own SEO projects for tagging and for various other things. And don't presume any mention of BERT just automatically refers to Google BERT, just one part of it. And as I said, this is Albert. Maybe there's parts of Albert in Google's BERT in practice, probably because it's more efficient. And obviously, even machines like Google and massive companies have to consider cost and efficiency as well. And algorithmic bias is a massive concern now because of these black box algorithms. Again, I encourage you to go and look at the work of Ricardo Bieza-Yates, who's spearheading a huge field of works into bias on the web. There is bias on the web, and unfortunately it's being baked in a little bit by some of these machine learning models. There's something called the No Bias Project, which again, I know Ricardo's a big part of. That's a huge piece of research that's being developed now by quite a lot of PhDs, and it's been funded by the European Union on to try and build systems to combat artificial intelligence that goes a bit rogue. So responsible AI, if you like. And as I say, sometimes BERT actually doesn't know why it makes decisions. So that's an example of algorithmic bias potentially. So these are all like, if you like, brave new world things that we must take into consideration. So yeah, so obviously any questions and answers that we need to go over, I'm happy to address them now.
Awesome. Wow. I mean, wow. You clearly understand a big space in this. I do have one real quick question that I wanted to kind of ask, and that's, you know, we've kind of seen this progression towards a lot more machine learning and a lot more, you know, kind of AI-driven algorithmic updates, and basically Google's use of their various different technologies to kind of improve search, as they would say it, or change search, or kind of improve the search process. Do you see this as like a major step moving forward as far as, kind of allowing, conversational search to really take a place where it's kind of historically been pretty bad.
Yeah, I mean, this is a massive leap forward. But if you do follow the work of, if you do follow a lot of the IR research out there, there's still a long way to go, long way to go. There's a lot of work going on at the moment around clarifying questions in conversational search. There's a chap called Mohammed. I can never pronounce his surname. Alabadji, I think his surname is spelled. But he's just done his PhD on clarifying questions in conversational AI to disambiguate, and he used BERT in his research papers. And that was basically a back and forth, if you like. So one-shot answers are really, really difficult, yeah, because there's also these notions of the user's context as well as words context. So what's the user doing? What's the intention of the user? What's their scenario? Are they on a mobile? Are they crossing the road? Have they got one eye on the screen? Have they got one eye on the road? Are they, are they on a bus? Are they a passenger in a car? Lots and lots of other things come into play as well. And it's far from perfect, but I believe that this is going to take a hockey stick move forward in the next year, 2-3 years, something like that. I know that Google last week, I think it was one of the conferences, I think Gary said it's quite expensive, computationally expensive to implement BERT, or it might have been at the actual webmaster conference in San Jose, where they said it's actually computationally expensive. I don't think it's used for everything. And obviously they don't tell us exactly how much machine learning they're using in search, but I imagine that as things become more efficient, that it'll be implemented more and more everywhere, if you like. And obviously there are all these issues with responsible AI as well, the bias thing creeping in. So they have to test things extensively before they can just throw them out into the wild. I know that Jeff Dean, I think it was Jeff Dean who announced, or I'm trying to think, was it Pandu who announced Google BERT actually been implemented in search. He said they've tested it for quite a long time, and I know it was a collaborative work between research and the research team and the search team together. So they can't just throw things out there because things could go very badly wrong. But yeah, I see it taking quite a hockey stick move forward now, accelerating
Awesome.
things. Yeah.
So again, really, really great information. I think this is probably the deepest I've heard anyone speak about BERT to date. And I think that anybody listening truly has like a really good, I mean, I think it's not only a good understanding of what BERT is, but a good understanding of what it means for kind of the progression of search as a whole and where we're going and kind of what we're trying to accomplish. And I think that, one of the things that we've tried to really emphasize as, kind of leaders in the search space is to not focus on another checklist kind of aspect, but to really understand fundamentally where search is going, where the buying cycle is going, where the research cycle is going, and being ahead of it. And I think BERT is a really big precursor, and this explanation's a really good explanation of kind of where things are going and how you mentally need to approach marketing in the future. So I'm super happy to have you kind of break through things.
There is no checklist with this. There's no checklist with this. There isn't, because the checklist could change. A, it's machine learning. B, it only takes for a search engineer to tweak a few weights and button features. And what's the point of trying to learn, BERT works this way when it might work differently tomorrow or in 10 minutes? It's just not, it's a zero-sum game, really, for that kind of behavior, in my mind. That's
No,
maybe just
I agree 100%. So we do have a handful of questions that we were able to gather together. What we're going to do is we're going to get those questions over to Dawn and have her kind of answer those questions in email for us. And we'll make sure all those questions get included in the recap post, which will be available if you're listening right now. It should be Monday when the post should be available. So thank you, Dawn, for taking the time. Thank you for sharing all of your information, which is clearly not just BERT, but like a historic understanding of what BERT really means. And I think it was super informational, and I really appreciate you spending the time with us.
No problem. And thank you again for asking me. I really appreciate it.
Cheers. Thank you.
Thanks.